So we now know how to make our own functions. We're going to make extensive use of that from now on, that knowledge. And I will finally get us close to what Scratch has been doing for us very easily, right? We've been making animations, or we did make a bunch of animations super simply in Scratch, but it's a little bit harder in Python, so we had to wait a while. But I can give you some animations today too. All right. So let's first talk about functions again. Let's just remember what they're all about, and so I'm going to be making a lot of them. Okay. So the whole point of making a function is so that you have a piece of code that you can keep coming back to, keep rerunning it, because you've noticed that you don't want to copy and paste things all day long. Right? You want to rerun it with in a different way each time. Usually, you're going to have parameters and arguments and stuff like that. So a function is a rerunnable piece of code, and the whole reason you'll make a function so that you can call it multiple times. And again, it takes parameters, and you call it with things called arguments. Okay, so let's see here. This is kind of how it works, right? You say def, you give the name of your function, func name, whatever it is, and you give all the things that it takes to call it. Give it these are called the parameters. Parameter 1, parameter 2, let's say. So there's 2 parameters. And then, given what you've been given, I guess, go and tab over and give all the lines of code to use P1 and P2 to do the thing you set out to do. Okay? So that's the job. Sometimes functions just go off and do something for us. Other times, functions return values back, like square root, for example, in the math library. That's going to return you back the square root. It's not going to print it or anything. It's your job to use it in some bigger context. Okay, so that return statement gives a value back to the person who called you, gives something back to, we'll call that the caller. Whoever called you, they're the caller of your function. Okay, and yeah, the way that you call it now is you'll say something like func name 42, 43. You say its name, you give arguments, and those will be passed along into the parameters. And if your function doesn't return something, then you're good to just call it a line by itself. It goes off and does the thing. But if it does return something, then you should be calling it more like this. You'd be like func name 42, 43. Those arguments, and shove the answer into some variable or something, or print out the answer somehow. And yeah, when functions return things, you get to pretend that what they return is replaced by the call. So this turns into maybe a number, you can add 1 to it, something like that. All right, so that's what works for functions that return things, but other functions that don't have returns in them just go off and do something for us. Okay, and we will talk about the difference soon, but a good example of a function that just does something is the print function. Right? You don't expect it to return anything back to you. You don't add 1 to the result of print. And that versus math.square root. You got to use the answer that math.square root returns back to you because it gives you something. Okay, so that's functions in a nutshell, coming back to us hopefully. And now I'd like to combine a lot of cool things together. Let's make a function that draws a rectangle. Okay, let's do that. So I want to make a function called draw rectangle that I can call draw rectangle with something, right? How many arguments? I'm not sure. And that somehow, if I give it the right stuff, I can represent exactly, right, this particular rectangle. So now the question is, what do you pass along? How would you represent that rectangle to this function? How'd you tell it? I want exactly that rectangle, no other rectangle. Do you have any ideas? Yeah, you can pass along side lengths. That would work, widths and heights. But then, how would it know whether or not to draw this triangle or this rectangle versus that rectangle? Same side lengths. How could you make sure it's up here? So you need to pass along where, one of the corners or something, yeah? So yeah, that's what I'm getting at. Good. So one way to call draw rectangle is you could pass the 4 corners of the rectangle. That's a lot of work though. That's something that would represent exactly that rectangle in space. Or honestly, all you really need to represent a rectangle, the minimum amount of information is kind of the height and the width. So maybe this is 4, maybe this is 3. And then you just have to pin down one of the corners. Because once you've done that, Okay, and the upper left corner is at like 1,5 or something. The second you've done that, and then you give the width and the height, then you have exactly that rectangle. Everybody knows which one. Does that make sense? That's like the minimum amount of information. And so those are the things that you could pass. We can make our draw rectangle function work exactly like that. Like pass along the upper left corner of the rectangle, pass along the height, pass along the width. That is a rectangle. Cool. And so one way to pass along multiple values, like a coordinate at once, that's like a list. You could pass along 1, 5 a list. That would work. There's actually one new kind of thing in Python that is similar to lists, but it looks more like coordinates. You can trade these square brackets for parentheses and say 1, 5 in Python, and that creates a new type. That creates something called like this kind of value. It looks exactly like a list. It's called a tuple. Okay, it's called a tuple, and so it holds those things just as if it were a list. It holds both of those things at once. The type is called a tuple. Let me show that to you real quick. I'll go to idle, and I'll just work in the REPL for a second, like I was doing there. It's like 1, 5. You can represent that. Shove it into a variable. This is so just like what's the type of this 1, 5? That's a list. If you do this one, 1, 5 within parentheses, that's a tuple. Okay, so it's the same idea. It works exactly the same. You can get the pieces in exactly the same way, like x of 0, x of 1. The indices are exactly the same idea. It's just like the type is tuple. Okay, some people pronounce it tuple, but I learned tuple. So, and so we can pass a tuple, right? A tuple for the coordinates of the upper left, and then like an int for the width and the height. Okay, that will be what our function can take. And once we're given it, we can extract the x coordinate and the y coordinate by like going to those indices of the tuple, just like it were a list. Okay, so let's do that. Let's actually do that in code now. I'll make a draw rectangle function in a brand new file for the day. So let's see here. First, I need to make a new file. I need to save it somewhere. And what lecture is this? Is now the question. Looks like it's lecture 24. And I will call this, I guess draw rectangle would make the most sense, right? Draw rectangle. And now let me like resize all these windows because they're way too big. Go over there, go over there. So we know right now, whatever I need to do, it's got to be def draw rectangle, right? That's the bare minimum that I need to type right now. Def draw rectangle. A bunch of stuff in here, and then a colon. Right, so that's the bare minimum that I know I need. Let's figure out the rest now. Okay, so what parameters should it have? What does it need to take? I say def draw rectangle. Well, we've decided that one way to get a rectangle and represent it in a way that everybody understands is like you need at least one corner of that rectangle. Got to pin it down, and we'll use the upper left corner. We'll pass along the upper left, and we'll get that first maybe, and then pass along the width and the height of that rectangle. All right, so call that UL, W, and not L. We'll call it H for height. Okay, and then, well, what do you do? What do you do? Let's figure this out together. So UL, first of all, we're passing along as a tuple. Like so, we can call it. We're going to call it like this: draw rectangle. This is a function that is not going to return anything. It's just going to go off and draw something for us in the turtle land. So that R is supposed to be next to a W. That's better. Rectangle. And like if I wanted to draw this exact one, I'd pass along the tuple 1, 5. And then the width was 4, the height was 3. So that's how I would call it. Just go off and draw the rectangle once I implement it. All right. So that's this part is a tuple. Remember, it's just a list with the different kind of outside thing. Okay. So there's that. And like now, what do you do? How do you draw this rectangle now? Well, you kind of just like you got to go to UL, right? It's kind of like the first part. Go to UL. This is not really Python. It's pseudocode. Like go here. Go to that UL coordinate and start like face right or something, and then like go forward by the width, right? Go that way by the width, and then like turn right 90 degrees, go forward by the height, right? Turn right 90 degrees. It's not supposed to be an arrow, is it? Go forward by the height. Turn right 90 degrees, go forward by the width, right? If we just did that, we would eventually turn right 90 degrees, go forward by the height one last time. That would give us our rectangle. So given all these pieces, we can use them, whatever we got, whatever was passed into us, like this 1, 5 is being shoved there, the 4 is going into W, the 3 is going into H. We'll use those to draw whatever rectangle the user wanted us to draw. And we can keep calling this function with different kinds of rectangles. That's the beauty of it. Okay. And then you can do more. You can think about like, okay, maybe I want this rectangle colored in. You can add like a color parameter and pass along like red or something as an argument. That's the thing. But let's get started. All right. So I need to do turtle stuff. So I need to import turtle. For sure, I like my turtles to look like turtles. So turtle.shape turtle. Outside of all that, and then now we're ready for draw rectangle, and we know what it's going to take now. We know it's going to take UL. This is the order of these things. UL, W, and H. And so that we can call it something like this. Down here at the bottom, we'll say like draw rectangle. I don't know, at like 5100, starting there at the upper left. Like a height, a width 200, height 300. So it's taller than it is wide rectangle. So that's kind of how I want to call this function. All right, and so I've got these things. Upper left corner, coordinates, width, and height of my rectangle. Now I just need to make this work, right? So what do? I need to, I guess, move to the upper left, right? Go to that coordinate that I was given. And then, like, face right, right? Because I want to face right so I can go forwards by the width if I'm starting here. So, like, face right. I'll just use comments to remind myself what I need to do. Face right, go forward by the width, right? Go forward the width, because that would bring me, right, from here to here. Now I'm sitting here. I'll, like, turn right 90, go forward by height. That makes sense? Turn that way. We know how to draw rectangles. 90 degrees, and then like go forward by height. And I think you get the idea at that point. All right, so let's turn these comments into code. All right. So how do you move to UL? It's going to be turtle.goto. Yeah. And then you pass along the x and the y coordinate of where you want to go to. If you are given a tuple, like I was showing you here on the REPL, if you want the first thing out of that tuple, it's the 0 index. You want the second thing out of that tuple, it's the 1 index. Okay. So the x coordinate is going to be in UL of 0, isn't it? And then the y coordinate is going to be in UL of 1. Okay? That's how I'll pick those out and get them in there. And then I need to move there and not draw anything, right? So turtle.up around that. Turtle.up and turtle.down. Now I'm in the right spot. And then I want to face right. How do you do that? That's going to be, there's a few different ways, right? There's set heading, I think, is probably the easiest one. Turtle.set heading. And then 0 is the 0 angle, so facing directly to the right, east. And then, yeah, that's kind of, let's see how it's working so far. Let's run this. Still got more to do, of course. So yeah, it looks like he went up there, he's facing right, now he's ready to go forward by the width. Cool. So I'll say turtle.forward by whatever W was, whatever was passed to me. Like, for this particular call, it will be 200, right? And then turn right by 90, turtle.right 90, and let's see this so far. Cool, now he's ready to go forward by height now. See how it's working? Whatever the height was, go forward by it. That's going to be shoved into my H parameter, whatever was passed to me. I'll use that. Use that H value. All right, let's watch that work. Oops. There it goes. And so it's ready to do the rest, and I think you understand the rest. It's going to be another right 90, forward by width, right? And then one last right 90, and forward by H, the height. And that should draw a nice little rectangle for us. So again, I've got the code to do the drawing, that's the function, and then I'm calling it down here at the bottom, okay? With those particular arguments, give me this particular rectangle. Cool. Are there any questions about that and why it's working? It's pretty neat, I think. So again, the whole point of making this function is so you can keep on calling draw rectangle all day long. Be like, all right, I want to draw down the rectangle now. I'm going to pass along, all right, let's have it start at upper left corner, -50, -100. It'll be a baby rectangle, 50 by 30 or something. How about that? And then I'll draw another one. Why not? Let's draw a rectangle at 0, 0. Upper left corner at 0, 0. And it'll be a perfect square, so I'll pass along the same length, 75, 75. How about that? So that's the beauty of functions. We'll just keep on jumping up here with the different values, like in the UL, and the W, and the H each time. Magic of functions. Cool. So let's watch that work. So I got 3 calls to draw a rectangle. It's going to jump up here 3 times with different values for UL, W, and H. I get some fun abstract art that way. Okay? Does that still make sense? Questions about any of that? So that's the magic of functions. You keep on calling them. And this function doesn't return anything, just goes off and does something, goes off and does the rectangle drawing for us. Okay? So, let's see here. What next? Let's next talk about like color. Let's add a new parameter. Let's say that we can pass along now that we know how to draw a rectangle, we know how to fill it in too, right? Let's have the user be able to pass us a color that they want that rectangle to be colored in as. So let's say I want to call it like this now. I want to call it like, I don't know, fill this rectangle in all black. It's a black rectangle. This one can be a red rectangle. This one can be a blue rectangle. Really a square, that one, right? Because it's the same width and height. So now I just need to add a new parameter, right? It's going to get that thing. We'll call it color. And then, all right, how do I change my code to draw a rectangle filled in with whatever color holds, whatever string we got, like black or red or blue, anything? So now I just need to set, what was it? I guess you could do either the pen color or the fill color. Let's just make it easy. Let's do the pen color. That will just be the outline. And you can change this code once I give it to you, maybe, to use it to fill in with that color instead. Let's do turtle.pen color, though. That's the outline color. Set the pen color to whatever it was. Like, you could set it to green, or whatever, but let's pass along, or let's use whatever color we were asked to color it in as. Okay? So that's a very one-line simple fix, right? Super nice. So we jump up here with these different colors. It's going to change the pen color and draw those rectangles with that outline. All right? Highly encourage you to change this to be like, to use the begin fill and the end fill to actually fill in these rectangles. But now we have different colors too. So that was super easy. We just noticed, all right, this is how I would like to call it. Let's add a new parameter to get that thing and then do the right job with it. Okay? Does that make enough sense still? Any questions about this example before I do something similar yet different? All right. So my best next example that's similar to rectangles is let's make a function to draw a letter. Okay? And those letters can be resizable, right? Because what you did in your programming assignment was like you drew your initials and then you drew your graduation year. But let's make some functions instead. Because like, what does it mean? I told you like to think about it like you're enclosing your letters within a rectangle. Like, what does it mean to draw like an L, for example? Like, really, if you're going to draw an L, you're just going to have to pick a width and a height, don't you? So there's really a bounding box to every letter that you would draw, and number. So there's always a certain width and height to it. So we can make like a draw L function. There's a width and a height. We can totally make a draw L function. It's like go to the upper left corner, right? And then start drawing. Start making lines. L like that, L like that. Cool. And then just as easily, we could make another call to our draw L function with like this kind of width and height. Looks more normal. With a different kind of width and height. Smaller width than the height this time. And then we can go off and be like, all right, go to the upper left corner there and draw this L down here. So every letter has a bounding box. You can think about it like that. So like, we can make a draw L function, can't we? Just by calculating, like we're going to be passing along this upper left width and height. You can use that, right? Just like the draw rectangle function to draw an L character, couldn't you? Of that particular width and height starting at that upper left corner, all right? So let's make it a little bit fancier. Let's do an N for my last name initial. Let's do that one. So again, we can bound every letter we want in a rectangle. All you need is to pass along the upper left corner, like where do you want this n drawn on the screen? And what is the width and what is the height? There's your UL width and height again. And you can go off and you can draw your n. Like you can calculate these coordinates, right? Do that, yeah. And you could pass along in a different way, right? A different upper left corner coordinate. A different width, a different height. And you can go off, all right? You'll calculate those coordinates. Draw the n there. See that? So what I would want now is a draw n function, right? Def draw n. And it'll take the same things that the draw rectangle took. Upper left, width, and height. And it will draw an n within those bounds, okay? And that's what we'll fill in. Does that kind of make sense? So it's very similar to draw a rectangle. And you can see the power of functions, okay? So given some rectangle to fill with the letter, we can draw whatever we want and have it like fill up that bounding rectangle, okay? So, done. Let's spell it out. I guess let's get it working. Let's get it started, and then I'll copy most of this code, right? So instead of draw rectangle, I'll call it draw n dot pi. And what are we going to do? Well, it's not draw rectangle anymore, it's draw n. And it doesn't need a color anymore. We're not going to deal with colors. Maybe you could add that back in if you want to them. And it's going to be called draw n. Let's draw 3 n's. Why not? The same vein, right? But we just won't use the colors. So I'll get rid of those again because I got rid of that parameter, so I can't pass along a 4th argument anymore. So yeah, now I just need to change this to draw an n instead of this rectangle. Okay. So how do we do it? How do we do it is the question. Well, we have to go to our upper left corner coordinate, right? What we're given is some representation of a rectangle. We're given the xy coordinate of the upper left, so we got to go there. I'm bad at drawing straight lines. I need to bring like a ruler. That's the best I can do. Right, so we are being passed, right? We're going to pass along this xy coordinate of the upper left corner of the n, and then a width and a height. And so really, what I need to do is calculate, right? I know xy, I know this already. I need to calculate the coordinates of all the corners, don't I? Because do you see how if I just like go to here, then go to here, then go to here, then go to here, in that order, it will draw the n for me? So I just need to calculate those coordinates first, and then just use go to a bunch of times. Okay. Let's figure out those corners. What are those coordinates? So like I want to start here. What is this guy? That is going to be, well, it's the same x, right? It's the same x, but it's lower. So it's a different y. It's lower by how much is now the question. So same x, and it's going to be y minus h, going down h amount. You see that? That's how you can calculate that coordinate. Whatever the upper left y was, minus the height, though. We're going down. So start there, then go to here, right? Go to normal xy, upper left, xy. And then we got to calculate this coordinate. That's going to be, well, it's x shifted over to the right by width, isn't it? In the positive x direction. So this will be x plus w, comma, and then again it's going to be the same y. It's not this y, it's moved down by the height. So x plus w, y minus h, in the negative y direction. See that? And then just say go to there. And that will, if we do it in the right order, make that line. And then we need to go up here. Right? That's the last step of the puzzle. And that's going to have the same x coordinate as this guy, so x plus w. So starting there, go right, x plus w. And then it's going to be the same y finally. Not same exact y, it's on the same plane as that one, same level. All right, and then if I go to there after this one, it will draw that line in exactly that way. And it will be much straighter than my bad drawings. Does that make sense? I just need to calculate those things, and then if I go to those places in that order, I'll get my n drawn for me. All right. So what needs to change here now? It's like you still need to move to upper left, but actually, let's see here. I think, yeah, let me just get rid of all this. I think it would be easier to just start from scratch. So I need these x's and y's because I need to calculate with them. So I was using like, see, I was using ul0, ul1. Let's separate those into their x's and y's. Like UL, whatever this was, UL is that. And if I want the X part out of it, I'll say UL of 0. If I want the Y part out of it, I'll call it UL of, I'll get UL of 1, okay? And now I'll use a variable for those things, a local variable, okay? So now I have my X's and Y's split up, and I can now do my job. Draw a W by H N character. That's my job now. So where do I go to first? It's going to be this bottom part, right, isn't it? It's going to be X, Y minus H. It's not the upper left anymore. So I need to start at X, comma, Y minus H. So I need to go there. Go there with my tail up, though, so I don't make any marks as I move in there. But once I get there, I can put the tail back down. Okay, so it's going to be turtle.go to X, comma, Y minus H. Put the tail down, and now I'm in this bottom left, wherever it was, calculated that. I'll go to X, Y. And then I'll go to X plus W, Y minus H. X plus W, Y minus H. All right. And I'll go up a little bit more to do X plus W, comma, Y. That's the last place I need to go. Do those ideas make sense to us? Because that should do it. I do believe that should do it. And those are all the pieces. And you pass along your bounding rectangle, and it will go off. Calculate those coordinates. It's drawing a bunch of ends. Cool. Or like sideways Z's, I guess. That works too. Like somebody's sleeping. Yeah. Does that kind of make sense? The process that we went through to get that answer? We're good. Good with that? Any questions? I think what I would like to do is now give you some time to play around. Like I've shown you all this. I'll leave the code up, let's say. I'll leave the code up so you can type it down if you still need it. And what I'd like you to do is the following. Please try to change this code. I'll give it to you over here on the side here. Change my code to like make some other resizable character. All right, so instead of like an N, make an L. An L would be easy, right? Or make a letter that's in your name. Okay, give it a try and like draw in a bunch of different places. All right, so yeah, take a few minutes to try that, and please ask me if you have any questions about anything. This is a good way to practice and solidify it in your brains. We have plenty of time. Yeah, you might have to like break out the paint program. And the coordinates. All right, that was my time. Feel free to keep working on that, but I just want to make sure there's enough time for everything today. Any questions come up as we were trying it? I think it's really, it's satisfying once you get it working. So I highly, highly encourage you to keep going after class, even if you didn't get it in this amount of time. Yeah, let's keep on trucking. What I would like to do next is I'd like to make an animation finally. We've just been making static images, right, after the turtle's done drawing. I'd like to make the simplest animation I can think of is like a ball dropping, okay? So like what I would like to do, a very simple example, we'll make it complicated next time, but what I'd like to do is like I have a ball and like it starts up here and I like it to move. I get to move that way, hit the ground, and bounce off, and like go back up. And just like we'll pretend there's no gravity, I'll just like move at a constant speed, up and down, but bouncing off the walls. Well, that'd be cool. We'll show you how to do that now. All right. So to get there, we have to talk about the nitty-gritty of like animation, which we didn't have to worry about in Scratch. Scratch was very nice to us. It was handling it all for us. But in Python, we have more control, and so there's more to worry about. Okay, more to write down, and the programs get a little bit longer, but we have the fine-grained control that we didn't get in Scratch. So there's a trade-off there. First of all, let's remember what animation is all about, right? All animation is just a bunch of moving pictures, like a bunch of pictures shown to you in rapid succession, right? That's what I think they still use film at, right? Like at theaters. I don't actually know anymore, but like you know what film is, right? You got a bunch of pictures like of your movie, and just like it shows you those pictures very quickly, like what is it, 23 times a second? That's the frame rate or something, and 24. As we're in the theater, it makes it seem like they're right in front of us, that they're moving. We don't see any choppiness. Okay, so what we want to do, if we want to produce our own animation, is we want to show a bunch of different images to the user very quickly. And each image is called a frame, right? So we have a bunch of frames. Maybe you've made like a flip book before and you've done something like this. But like we want our first frame to have like the ball appear, right? Because we want to start it there, and then like show that to the user for a little bit of time, and then very quickly draw the ball here, a little bit further down. Yeah, that's kind of the game. And I was like, all right, the next frame after that is going to be the ball's even further down, so it's moving. And it's like you're going to keep on drawing pictures like that and showing them to the user. Those are your frames. Those are the frames of your animation, okay? And then like the faster you change the images, the faster your frame rate. So maybe you've heard that word before. And so like I think a standard movie frame rate is like 24 frames per second, 24 FPS. All right, and that's how fast they show you images, and it seems fine to us. And so we have to draw then, if we're going to do it that way, draw a new frame every 1/24th of a second. Okay, and computers can do that. Like you have video games that can go at 60 frames per second or even more. Not an issue for us on a computer, but that is what we have to worry about kind of now. Okay, in Python, we get that level of control kind of. All right. But I'll try to make it as easy as possible. We won't really worry about the frame rate, but like this is what we must do. We have to draw a picture, show it for a while, draw a new picture, draw a new picture, draw a new picture. Okay, and that's what we're gonna do. All right, so let's make a ball that gets dropped and keeps bouncing just up and down forever. Okay, and I'm gonna make a function called draw frame, just like to make this easy on ourselves, and we'll make it as nice as possible for us. Okay, so The first thing I want to do is, like, everybody's screen is different. I think on your big laptops in idle, when you load a turtle program, I think it's bigger actually. You get a bigger coordinate space than by default than what my laptop shows. And so let's make it easy and the same for everybody. And so let's draw a rectangle that is going to be the bounds of where the ball can fall. Okay. We'll use our draw rectangle function for that. All right, so I'll draw a bounding box for my scene. So I'll do that up here or something. Like this will be the bounding square rectangle for my scene, and that's where I want the ball to be dropped. All right, let's say it's like a 400 by 400 rectangle centered at like 0, 0. Okay, that's where it's going to be. So that's going to be the scene, and then the ball is going to start right at the tippy top, something like up there. Okay, and that's going to be the goal. All right, and it's like have it keep on moving up and down, like bounce down, then hit off the bottom, go back up. Okay, just keep on doing that until the end of the time. So, okay, if I would like to do this, first of all, I want the scene. I want the bounding rectangle. So if it's going to be 400 by 400, centered at 0, 0, what's the upper left corner? So I can use my rectangle function. It's going to be like go left 200, go up 200, right? So this upper left corner then is going to be negative 200, positive 200. So let's get that started. All right, let's get that started. I'll call it... let me steal my draw rectangle though. There it is. I'll steal the draw rectangle program, Cappy, and I'll make a new file and call it bounce. Bounce.py. Get rid of these guys. And then I want my draw rectangle function to not deal with colors again. So we're just going to draw a black rectangle. The default is fine. And so I guess I'll hook into this first one. I want a 400 by 400 bounding box, please. Centered at 0, 0. So the upper left then is negative 200, positive 200. Okay? Negative 200, positive 200. And this will be my bounding square. Draw the bounding square. That is like the walls that the ball will bounce off. Okay? And so that's an easy start, and this is like now, regardless of whether you have a giant screen in front of you or a laptop, you know the walls where the ball will bounce off of now. All right, so that's that, and then we need a ball to bounce. All right, so we just got to draw a ball very quickly. We're gonna cheat a little bit though. Okay, we're gonna cheat a little bit though. An easy way to get a ball actually. Let's see how I want to explain this. An easy way to get the ball is actually just to use the turtle. So the turtle is shape right now is turtle. There it is, turtle.shape turtle. But there are other shapes. There are other shapes that you could use. And let's go to the turtle library documentation. So Python turtle shape. We can make the turtle shape a circle, and that's going to be very close to what we want. Okay, turtle.shape circle. And we're going to make the turtle the ball. That's the secret. Okay. So we've got the bounding rectangle good to go. And then let's make the turtle the ball. That'll be fun, right? So let's say turtle.shape circle. You give it as a string, so single or double quotes, doesn't matter. And let's give it some color or something. But let's look at what happens so far. So there he is, his little ball. He's a circle. Let's make him a little bit bigger and like a different color. So we'll do turtle. It's the fill color that changes the inside color of the turtle. So we'll do that. Turtle.fill color. And I'll pass along like pink. Be a pink ball. And what you can do, if this is too small of a ball, and I think it is, you can make the ball bigger. You can expand the size of the turtle, all right? Because the turtle is the ball. And so the way you do that is it's going to be turtle size somewhere. Where is it? There it is. Turtle size. And you can stretch him along the width as well as the height of himself, the x-axis and the y-axis. We're going to stretch him the same on both axes, so he's still a circle, not an oval. I'll stretch him by a factor of 2. Okay? So I'll say turtle dot turtle size 2, 2. Alright? That's what I'll do. And there he is. And now I just need to put him up here. See that? So get him started. Get him in the right spot. So move him over here, please. So, let's see, what do I want to do here about that? Let's get his, well, we'll think about this, right? So here is, what are these coordinates, right? We have to think in terms of coordinates right now. This is positive 200, right? If this is 0, 0, 0 right there. This is positive 200 on the y, and 0 for the x, right? So 0, 200 is maybe where we should put the turtle to start. Go to there, please. With the tail up, of course. So let's see. Let's get him in the right spot. We'll say turtle dot, pick the tail up. So our job right now is to put the turtle in the correct starting location. Turtle dot up, so he doesn't make any marks anymore. Just gonna move him. And turtle dot go to, so 0, 200. Let's figure this out. Not quite in the right spot. But are there any questions about how I got to this? We just need to move him down a little bit, right? Because the turtle's coordinates are relative to his center. And so what we need to do is go down half of his size, half of his diameter. Yeah. And then it'll be just grazing that wall, which is what we want there. Okay? So yeah, the problem we just found is okay, his coordinates are relative to his center, so he's kind of right here. We need to move him down by that much. That'll be grazing the wall. Okay? So let's figure this out. And what I'm going to do, just to save ourselves some time, is I'm going to use some variables. All right? I'm going to keep track of where the turtle is in some variables so I can keep changing those variables. Okay? That's what I'll do. I'll say turtle x, and I'll keep on going to the coordinates that I'm putting into here. I'll make a turtle x variable instead of 0. So the x coordinate of the turtle should be 0. And then I'll also say turtle y. Turtle y, that needs to be, well, it was 200 minus his width over 2 or something. Minus the width over 2, that's where he needs to start, right? And I'll use those, okay? I'll use those to keep track of where the turtle is, which is the ball in our case right now. So, let's see. And he also has a size, and I had to, by default, apparently, you make the turtle a circle, he's 20 units tall by 20 units wide. By a factor of 2, then he's 40 tall by 40 wide. So his width right now, or his diameter, turtle width right now is 40. I had to think about that ahead of time. All right, so that's that. And then I'm going to make some variables. I'm going to say turtle x, where the turtle should start on the x is 0, and where the turtle should start on the y is 200 minus his width over 2. Does that make sense? That's where I want him to start, and then I'll tell him to go right there. Turtle x. Those variables to make my life easier later. All right. So yeah, the point of using these variables is so that I can keep changing them. We'll use these variables to keep track of where the ball is and where it should be. So where the ball. Keep track of. Let's keep it all on the same screen. Where the ball is. Where the ball should be. Where it should move. Something like that. So that's what we're going to use these variables for, and this should be the first starting place. All right, so go to straight there, please. Correct starting location after drawing the rectangle and everything. All right, so these are all working together, all these lines, to put the turtle right there, and that's beautiful. Right, just grazing the tip there. Does that make enough sense? How we got here? All right. Let's see. What did I just do wrong? I want to be here. Okay. So now, okay. Eventually, I just want him to move at a constant speed or velocity. Right now, just up and down, no gravity or anything. I will eventually, next programming lecture at least, I will add physics and make the ball bounce. And it's supposed to, if you're on Earth, it's speeding up as it gets closer to the ground because it's there's gravity involved. We're not going to program the gravity today. We'll do that next time, all right? What I want to do instead is just like move the ball at a constant rate. And so if you think about this in terms of frames again, I want to, if the speed is the same, I want the ball to have moved the same amount each frame. Does that make sense? Because that will be a constant speed at that point. Okay. So what I'm going to do is like, how do you change where the ball is? It's like you move the turtle, right? The turtle's up here. He's at turtle X, turtle Y right now. He needs to move down, okay? And he needs to move the same amount of downness every frame. Does that kind of make sense? That's what needs to happen right now. So if I want the ball to move just a little bit every frame, I want to change his Y coordinate, this is up and downness, right, to be a tiny bit less each time. Once he bounces, it'll have to be a tiny bit more each time. All right? And I'll use a draw frame function to deal with that, okay? So, but I need to like pick an amount, like how much am I going each frame? So let's call that turtle offset. Turtle offset equals something. It's going to be like a value that I keep adding into the Y to change it. If I want the turtle to move down, the offset should be negative. So I'll say something like -5. And I'll keep adding like -5 into the turtle Y every frame. Does that kind of make sense? And that will move in by that constant chunk of an amount. Okay? And so essentially, the fact that it was negative is going to give us move downness. If it was a positive number, it'll give us move up. This was +5. So once he hits the bottom, I got to make it +5. Then I'll move up a little bit. So he's going to move down a little bit because I'm going to subtract 5 each frame. 5, 5, 5. The ball will move down. So that's going to give us direction. The fact that it was negative versus positive, which is very cool, right? So once I've got all these variables working together, essentially what I want to do is loop, right? And loop and draw each frame. So repeatedly, what do I need to do? Repeatedly do the following. I want to mess with the turtle's Y based on the offset, change it a little bit every frame, right? Repeatedly set the turtle Y equals whatever it was plus the offset. Turtle offset. Okay? Change it by that amount. And then these XY variables have nothing to do with the turtle. We're just going to use those to like determine where the turtle should be. We also still need to do like goto, turtle.goto. So I need to redraw the turtle in that new spot. Does that make at least a little bit of sense? If I did that, kept on doing it every frame, moving the ball, right? That would change where it is, keep on redrawing it in that new spot. If I did that at a constant rate like this, I will get animation. Okay? That is the goal. So, okay, let's get there. So I'm going to make this easier on myself by using a loop and a function. Okay? So let's see, the first thing I want to do is like have an offset as well, right? Like how do I want this turtle to move? Turtle offset equals like start at -5 or whatever, okay? -5. And then what I want to do repeatedly, forever until the end of time, is I want to draw a brand new frame. So I will handle that in a function. Does that kind of make sense? I'm going to make a function called draw frame that will just take care of dealing with drawing one new frame. That will like move the turtle, do all the things it needs to do. Draw frame, it will be draw frame's problem for all of them. Okay? It's like this is very, very easy. Redraw loop. Alright? Draw frame will do everything it needs to do. So it's just like repeatedly, this is what that means, right? Repeatedly draw a new frame. Okay? So that's what I need to do. And now I'll do def draw frame. And, alright, what I need to do is set the turtle's Y to something new. So I gotta say turtle Y equals turtle Y plus turtle offset. So move them down by 5 or something, whatever it was. So change the turtle's Y coordinate by the offset. Something like that. And then I want to redraw the turtle. Okay? But actually, because I'm changing a variable, remember global versus local, this is a function. These variables are global variables. If I want to mess with one and change its value, I have to say global. I have to mark it. Tell Python that. And it's a little weird. So I just got to remember to do this. Global turtle Y, because I'm changing turtle Y. I will also eventually change the offset, so I'll say global turtle offset. This just lets me change them later inside of this function. So it knows to not make a brand new local variable. Use the global ones, please. Okay. And so I do that and I redraw the turtle. All right, redraw the turtle, and that's just like turtle.go to the new turtle x. I guess we're never changing the x. So the same turtle x and the new turtle y. All right, I just keep on repeatedly doing that, changing it. And I do this every frame. Move the turtle a little bit, draw them in that new spot. Move the turtle a little bit, draw them in that new spot by goto. Okay, that should do it, right? Will give us animation. That's the name of the game. And so we start at that starting point. And we'll just keep on. We're moving down, right? Because we got a negative offset. Watch. There's no errors at least. Bounding box. Turtle up at the start. Whee! There it goes. And obviously we have to program how it bounces off the wall. But like that's a good start. Does that make sense? Are there questions about that so far? This is surprising. It's very fun, right? It's a lot of work, but it's fulfilling, I would say. So that's what we got to do. What next now? I think the last thing we need to do really is just like bounce when he hits the floor or the ceiling. Got to notice that and like check. Okay. So it's going to be an if, a bunch of ifs. Okay. So we need to know like if we hit a wall, we got to bounce off. So when did we hit a wall? Now is the question. It's going to be right. It's gonna have the same kind of calculation again, isn't it? It's like if the y is right here, 200 minus y over 2, that means you have hit the top wall, right? Or you've tried to go past it. There's something similar for down here. What it means for the turtle to be right here is he's at negative 200. That would be bringing right here plus width over 2. That kind of makes sense. That's kind of the calculation we have to do here. So depending on your offset, you might have been up here. And then you might have moved the turtle outside even. So like we need to check like is the turtle Y like exactly grazing the bottom or even farther down? We need to check that. Depending on the offset, it might not be exact. Okay. So let's check if we hit like the bottom wall. The bottom wall, like I just said, is like if turtle's Y, we just exactly hit the bottom wall if it's equal to what that's negative 200 plus the turtle width over 2. All right, but it just may so be the case that like we were just 1 unit away from the bottom and like we subtracted 5 and now suddenly we're trying to go past the bottom. So it's not good enough to just check for equal to. It's all right if we try to move it, if we're like we want the turtle to be here or any smaller than there, that's definitely exceeding the bounds. We have to like rein the turtle back in, like make sure he's just grazing the top or grazing that bottom wall. All right, so that's that one. So this condition now, what it's checking for is if we get in here, right, we either exactly hit the wall, hit that bottom wall, or we're trying to go somewhere below it. We don't want to do that either. To go below it. All right, so what we want to do is rein that turtle back in. Okay, so move the turtle back inside to just graze the top wall again. Like if his Y was even smaller than this, like make sure it's exactly that now. Make sure he's grazing the bottom perfectly. If he wasn't, he's trying to go outside. And then he was going down here. We don't want him to go down anymore, right? We brought him right here. The offset is going to bring him down some more right now because it's negative. We want to make the offset positive to move him up in the next frames. Does that make sense, that process? So if you hit the bottom wall, you have to negate your offset, change it to positive now, because that will let you move up in future frames. All right, so change the turtle offset so we move upwards now. And not just like whatever the turtle offset was, we know it was negative to bring us here. We'll make it positive. Turtle offset equals whatever it was, just like times -1. We'll do it. Okay. Does that kind of make sense? If it tries to go outside, we are good. We are handling that. Even if you try to go even further outside, we'll rein you back into just graze the bottom, and then we'll make sure in future frames you're moving upwards now, because your offset will become positive by multiplying it by -1. And that should do a lot. Cool. Oh, much it worked. Bam! Now we have the same problem with the top one. Nice. Does that make enough sense so far? It's a little complicated. It's a good one to come back and study, but I really like this example. It's a fun one. Just we have animation again now. All right. So I could technically do an elif here because we can't hit both walls at once, but it's easier to just do a separate if, I would say. It's like if it hit the top wall, or the bottom wall, do this. If it hit the bottom wall, or if it hit the top wall, do this other thing. This is easy. To just do another if. Doesn't really matter. It could be an elif, but this will be a the other one. All right. So how do we know if we hit the top wall? So again, either we're just exactly at the top wall, so our y is exactly 200 minus width over 2, or like we try to go above it. So we need to rein it back in again. So we're gonna compare against 200 minus width over 2. Okay. So if the turtle's y is exactly equal to 200 minus the width over 2, we've hit the top wall. This is the top wall. Or we're trying to go above it. So that's exactly, we've hit it, or we try to go past it. So like the y is even greater. That's where we want to put it. No, we don't want to do that. All right. So just rein the turtle back in to be exactly 200 minus turtle width over 2. Exactly hit the top wall. And then to hit the top wall, that means our offset was positive, bringing us up. We don't want to go up anymore. That would bring us outside again. We want our offset to become negative to move us back down in future frames. So again, this code stays the same. Like it was positive, we'll make it negative by doing times -1 again. All right? So I think that should do it, actually. Let's see. That's some great code to study. It's fun to get this working. Look at it go. Isn't it beautiful? Are there questions about what's happening here? It's really just this loop down here. While true forever, draw a new frame, which just nudges the turtle a little bit in whatever offset and whatever direction we've chosen. And we're just using if statements to check, did we hit the bottom wall? Did we hit the top wall? If so, make sure our y never exceeds those bounds and change our offset so that in future frames, we're not trying to go outside anymore, trying to go up or down. If we were going up, now we're going down. We were going down, now we're going up. That's going to be a change in the offsets sign. Okay? Isn't that fun? Let's see here. Notice that I never talked about frame rates. I never talked about 1/24th of a second or anything. Honestly, we're kind of just hooking into Python to give us a frame rate right now. It's we're telling Python to do this as fast as you can possibly do it, essentially. And so it might actually be faster on your machines because they're more powerful than my laptop. Because of that, it can do Python faster. But you can control it. There's a way to do it. But we're just letting it go as fast as Python can do it. It takes a small step of time to do turtle.goto and redraw it and all that. And we're just hooking into that essentially. But it's all going to take the same amount of time because we're not doing anything vastly different every frame, every loop, right? So if you do want to control the speed in some way though, you can change what this offset was. We're moving by 5s at a time. If you make that a smaller value, the ball will move by a smaller amount each frame. So it'll produce a slower animation. Maybe that's more pleasing to the eye, I don't know. Whee! Ever so gracefully, it's falling and bouncing up. It's on the moon now. But yeah, this is, I don't know, this is very calming to me at least. But let's try to walk through what we did, and then we might change it one last time. So, okay, what we do at the start of this program is we drew a bounding rectangle. Right? We had our draw rectangle function, we hooked into that, we called it in this way. So there it is. Then we chose to use the turtle itself as our ball. We've made him a circle, we stretched him out, changed his color, and we remembered how big he was, so we can use that to our advantage later. And then the starting point for the turtle is going to be very tippy top, just grazing the top. So that is x is 0 because he's in the middle, and then the y is 200 minus width over 2. So you bring him down just a little bit to just graze the top, right? And then we go to there, that's our starting point, that tippy top. And then forever, until the end of time, we're drawing a new frame. And what do we do every frame? We nudge the turtle a little bit by our offset, starting negative, of course, because we're up the top, we're moving down. And then we keep on checking, did we hit a wall this frame, or did we not? If we hit the top wall or the bottom wall, one of these will happen. This is the bottom wall. It's we tried to move the turtle even outside of the bounds, or we've just grazed the bounds. Either way, make sure we're just right on the line. Bring him back in if we try to move him outside, and then change the offset to be positive now, so that we're moving upwards in future frames. And the exact opposite is true of if we hit the top wall. Okay? You're still checking similar things though. And then we've just been messing with variables. We haven't been moving the turtle yet. It's always turtle.goto to actually move that turtle to that new place that we calculated it should go to. All right? I think that is all that I wanted to say about that for now. Are there any questions? It's a good one to study, I think. I love it. It's a fun lecture to get. So let's see. I think there's one last thing I want to do. Let's do like a random starting x coordinate for fun. Just remember the random library. It's like it's been in the middle. Let's like have it be a different bouncing every time. So the x coordinate will never change, but we'll just pick a random one each time. How about that? So I'll include the random library, import random, and instead of setting the turtle x to 0 and just like keeping it there because we never change it, let's set it to like random.rand int between like -100 to 100. So it's a different place every time we run the program, kind of. So let's see where it'll go this time. So now apparently the x was like a negative value, like -50 or something. That's the random value we chose. Now it's going to bounce up and down over there. Or if we move it to here. Let's see the random value it picks this time. Now it's like +50. So slightly different. Interesting. But yeah, that's going to be the example for the day. Yeah, I think that's all I wanted to say. So I'll give you this code. Please look at it. It's fun. And I think that's all that I wanted to do for the lecture. That's all that I wanted to draw, I think. Cool. And so yeah, if you understood any of that, like, that's good, right? You're getting this stuff. And that was a complicated program. All right. So do practice it with it. And do remember to do attendance before you go. It's very dark now, isn't it? The last thing I want to do is release an extra credit assignment. Let me make sure the date looks right to me. Yeah. It'll be due the very last week of classes, like the Friday before finals week. And what I'd like you to do, if you would like to get this extra credit, it'll be worth up to 5% extra credit. So just like the last one, kind of. I would like you to make a review video for Python. I've taught you a lot of Python. I'd like you to come up with your own examples and make a little mini lecture maybe, all right? And this will help you to study because, wink, wink, I will be asking you Python questions on the final exam. Okay. I couldn't ask you Scratch questions on the midterm because how are you supposed to give me your code? It's very easy to type text into Canvas. Okay. So I'm going to be asking you Python questions. And so this is like you helping yourself review and also your peers because you'll be posting it down here, like reply, and everybody gets to see your hard work. So like your peers will love you if you do this, and you will also get extra credit, right? So just like post a video of you going over some examples for Python, all right? So make up some new examples different to the ones that I did in class, all right? So here are your requirements if you want to do it. Please have a bunch of examples of Python concepts that we've covered in the class. Be as creative as you'd like. The only thing you can't do is like exactly copy something I did in lecture because that wouldn't be fair, right? It's got to be something new. But you can use my ideas as like a starting point. That's totally fine. Yeah, just like pretend to give a little mini lecture, I would say. Like pretend you're a teacher because I want you to review, right? Demonstrate some stuff that you're going over. Like here are loops. Here is my example of loops. Let's draw some stuff. I don't know. Just go over it and maybe you can draw pictures if you want to like break out the paint program, whatever works for you. But I just want to see you making up some brand new examples. Okay. And then yeah, if you want half of the extra credit, make a 15-minute review video with the 15 minutes worth of examples and going over stuff. If you want the full 5, then I want to see a 30-minute review video. Okay. Does that make sense? Any questions about the extra credit assignment? So yeah, I encourage you to take part if you would like. Just make sure that you got to make something new, right? You can't like go over my slides or something like that. That's too lazy. It's got to be extra for extra credit. Okay, so just like ask me if you have any questions about whether or not your plan is good enough. I would be happy to help you decide stuff. Okay, and then yeah, you know how to record yourself by now. I don't have to tell you, but yeah, that's going to be the extra credit assignment. Take advantage of it if you would like. I think that is all that I wanted to say. It'll be due the Friday, the last week of classes. I think that was like midnight on December 6th or something. That's what it'll be due for everybody. I do believe, and that was everything I want to talk about in lecture. Cool. So that is all that I would like to record for the day.